All right, so let's take a look at section 9.2. Okay, we'll split this over 2 days, and we're going to look at our final coordinate system, which is polar. And we'll make some comparisons between this and parametric, and between this and y equals form. All right, so up until now, the grid that we've been drawing everything on was a rectangular coordinate system. Okay, when we do function notation, that has an x and a y axis. And when you do parametric, it's still an x and a y axis. Okay? It's just your regular old Cartesian coordinate grid. Well, for some curves, that's not the easiest way to draw them. Okay? And they can be drawn easier on what's called a polar coordinate system. Right, so now we're going to get away from the idea of using a rectangular grid. We're going to look at using a circular grid. Okay, which also means we're not going to have an x value and a y value anymore. Okay, so a circular graph paper would look something like that. Okay, so the center is called the pole. You could also call it the origin. And rather than measuring a horizontal and a vertical distance, we're going to measure a radius, okay, how far we are from the pole, and then an angle on this circle. Okay, so those are the two key things we're going to have to find: a radius and an angle, okay, not an x and a y. Okay, so what we'll do to represent our radius is that'll be r, and we'll represent our angle as theta. Okay, and that's what a point looks like in polar. Okay, so an example would be 3, 30 degrees. So that point would mean you're going to go out 3 units from the origin, and then you're going to go counterclockwise 30 degrees. Okay, you can have a radius that's positive, and you can have a negative. You can also have an angle that's positive and an angle that's negative. So I'll talk about how we deal with that. So to graph a point, first thing you want to do is look at the r value. If r is positive, okay, you move from the origin to the right. Okay, how many units right? Well, depends on what the radius is. Okay, move however many units r is from the origin to the right. So it's kind of like the same thing you do with the x-axis. Now, if r is negative, okay, what you're going to do is start at the origin, and you're going to move left however many units r is. And just like with coordinates, r can be a decimal. Okay, so I'm just going to go back to the graph paper for a second. I could move out a whole number of rings from the center, or I could move out 4.5. Okay, right in between. Okay, so it is possible to have decimals. Okay, so r positive, go to the right. R negative, go to the left. Next thing we do is look at the angle. And I kind of mentioned it earlier, that point up there. If your angle is positive, what direction do you think you move? Counterclockwise, yep. So the angle is circular movement. So we don't want to use the terms left and right for this. We want to use either clockwise or counterclockwise. Okay, so positive angle, you're going to go counterclockwise. Negative angle, you're going to go clockwise. Okay, and you do that from where you ended up in step 1. Okay, so after step 1, you're going to either have moved left or right, and then from where you move, then go 30, whatever the angle is, clockwise or counterclockwise. Right, so we're just going to start by practicing how to graph points. Okay, one of the most basic thing you can do with a point, just graph it. All right. You can make your own circular grid, but if you really want, you can Google like circular graph paper, and it comes up, and you can print out like a sheet that has like 4 on the front, 4 on the back, kind of thing. If anybody needs circular graph paper, let me know, and I'll do that. I'll just print some out. All right, so we're going to graph the point 345 degrees. All right, so we'll start with our radius. James, my radius here is how much? 3. And is it a positive 3 or negative? Positive. So we're going to start at the origin. And Jacob, since it's positive, I'm going to go 3 units.
To the right.
Which way? Yeah, 3 units to the right. Right. After we go 3 units right, we're going to move 45 degrees. Is it clockwise or counterclockwise? Counterclockwise. Right, so just estimate it. 45 degrees. It's halfway between 0 and 90. That's it. That's the point 345 degrees. Any questions on that? We haven't gotten into it too much, but what shape do you think polar is probably very easy to, what shape is easy to draw? Triangles? Circles. Yeah, circles are very easy to draw in polar. Okay. Lines are very, very difficult. Okay. And that's kind of the opposite of rectangular system. In a rectangular system, lines are super easy. Just y equals mx plus b. Circles using x and y axis, those are a little harder. Okay, the equation is more complex. All right, so each one has its advantages. If we have time, I'll show you how you draw a line in polar. It's pretty complicated, though. All right, let's try negative 275. All right, so John, what direction am I going to start moving in?
To the left.
Left, how many?
2.
2. Okay. And then, Jen, we're going to go 75 degrees. Which way?
Counterclockwise.
Counterclockwise. So counterclockwise is going, it's like it's going down. And we have to go 75 degrees. So how much, or what quadrant will I end up in? Mm-hmm.
You'll end up in quadrant 3.
Yeah, I'm still going to stay in quadrant 3. I'm going to be close to the negative y-axis, but I don't cross it because this is a 90 right here. Okay. So there's the point negative 275. Any questions on that? All right, let's try 3 negative 60. Dominic, can you tell me how to graph that one?
Move right 3 and go clockwise 60 degrees.
All right, we're going to go right 3 and then clockwise 60 degrees. All right, so that should look, it's a little bit more than half, but not quite all the way. So maybe it should go right there. Okay, questions on that? Right, next one, we're going to graph it, and then we're going to try something a little different. Kanan, what direction am I going to move for my radius?
Left.
And how many units?
4 units.
Good. We'll left 4. And negative 3 pi over 2. How many degrees is that?
270.
Yep, negative 270. So clockwise or counterclockwise? Clockwise. So I'm going to go clockwise 270. And I end up right there. All right. So if I do that in degrees, that was negative 4, negative 270. Let me trace that in color. Okay, the direction I went. Negative 4, negative 270. What's another way to get to that point besides this coordinate? All right, so what would you use for a radius?
-4, 9.
Yep. That'll work. -4, 90. That's good. What's another way?
4, -9.
Let's see, 4, -90. So I could go this way and come in like that. And one more way. 4, 270. Okay, so that's right 4, and then around 270. Right, so how many basic ways are there to get to every point in polar? 4. You can go left or right, and then you can go clockwise or counterclockwise. Does this happen with XY coordinates? Like if I said, I want you to get to this point, can you write the point 1, 2 different ways? No. If you change anything about this, it's not the point 1, 2. Right? What we don't count is going around multiple times. Okay, so if you go right and you just make a couple revolutions before stopping at your point, that's a repeat of one of these. Right? So 4 basic ways to get to every point. And the reason I show you that is because if I give you a graph on the test and ask you to identify the point, it could be identified 4 different ways. Okay, so if it's a multiple choice question, you'd have to look for one of these 4. You'd never have 2 of these listed because they're all correct. Okay, but I could pick any one of these 4 as a way to identify that point. Questions on that? All right. How about 0 pi? Stays at the origin? What about the angle? What is that?
Be basically the same. That is a 180-degree angle, but it would stay at the origin because you haven't moved out any.
Right. Okay, so when you graph this one, what I'm going to check for is that you stay at the origin and you spin your pencil 180. Just like that. Check for the spin. So 0, comma, anything always stays at the origin with, just the right spin. That's all. Okay, so any questions on that? All right, but try switching it. Put 0 in the other spot.
Then it just
It just stays at the same point after you move back.
Yeah, this is just going to stay on the horizontal axis. Okay, it's just only going to go left or right.
So it goes right 2.5 and stays.
This one goes right 2.5 units. So just draw it in between the second and third circle.
So technically at the same time as it being 0, it's also rotated 360 degrees, kind of, in that way. Like it's the same angle.
Yeah, so anytime it's 0, yeah, you always be on the horizontal. Left, you just move left or right. So there's not too much to do there. We can't really plot points on the graphing calculator in polar, so this you have to know how to do by hand. All right. Any question on example 6? I'm going to skip over that. All right, so from all the graphing we did, again, I want you to realize there's more than one way to write a point in polar. All right, next thing. I want to figure out how to convert a point in polar to a point in rectangular. Okay, if I had a point in polar, what would I be given? Yep.
You're given theta and the hypotenuse of what you could turn into a right triangle.
Okay, so yeah, I'd be given a coordinate, which is really a radius, which we'll talk about in a second. And Brian's on the right track. And theta, which is an angle. And in rectangular, what is my goal? What do I want here? I want an x and I want a y. So somehow I have to turn an r and a theta into an x and a y. So let's just make up a point that has coordinates r theta. Bless you. And how do you think I'm going to convert this? Maybe we'll start with a diagram. What do you think I'm going to do? Which we've done many times before. Yeah.
Or you use the sine or cosine function, or find the x or y.
Okay, eventually that's what we're gonna get to. What do I have to do before I can even do that? Yep.
Make a triangle.
Yeah, I gotta have a triangle. What kind of triangle, John?
Right triangle.
Yes, a right triangle, which then allows me to use sine and cosine. Let's see, what about r? Where would that be in the triangle? It's your hypotenuse. And what about theta? It is one of the angles.
It's the angle that's right by the origin.
By the origin, yep. It has to go right there. All right, so now let's just give names to these two sides. Let's call the bottom side x, call the height y. What trig function could I use to figure out x?
Cosine.
And what would be my, before I rearrange it, just tell me what it would be.
Cosine theta equals x over r.
Sine theta equals what?
X over r.
Yep. And our goal is to get a formula for x, so how do you move that r?
Or r cosine theta.
Yep. Multiply by r. And there's a formula for x. Okay, based on that, anybody think they could tell me the formula for y?
R sine theta.
R sine theta. Does that look familiar at all? It's almost like a set of parametric equations, okay? For a circle, where r is your radius. Except, we're not looking at it as a parametric equation. We're just going to use this to calculate the x value of a coordinate, and we're going to use this for the y value. But it basically is a set of parametric equations. All right, so let's convert negative 200 to rectangular. All right. So what's my formula for x? Yep, Brian.
R cosine theta.
Okay, and can you go ahead and fill in r and theta for me?
2 cosine of 200. Well, it can't, the negative doesn't matter in a cosine.
That's true. We could get rid of the negative and the cosine. We'll just use the calculator. So, but that's a good point.
It doesn't matter in the sine.
What about my formula for y? 2 sine negative 200. And again, if you were thinking kind of what Brian was doing, you technically could put the negative in front. But let's just type it in the way it is. Okay, should I be in degrees or radians? Okay. Does it matter what mode I'm in up here?
Yeah.
Polar. Or, yeah, polar.
The green polar.
Should we be in polar? Does that matter? The only thing that sine and cosine care about is whether you're in degrees or radians. The only time it would matter if you're in polar or parametric is if you're going to actually press y equals and then graph something. Okay? If you're not graphing, it doesn't matter if you're in parametric. Okay? And I'm not graphing. Okay? But I do have to be in degrees. Right, so let's do 2 cosine negative, I'll put in the negative 200, and we get negative 1.88. And we have the one for y too?
0.684.
0.684. Okay. Right, now just write it as a coordinate. Negative 1.88, 0.68. Okay, any question on that? Okay, now what I'm going to do is check that on the smartboard. Okay, the way I can check it is I can graph this, on a polar grid, and then I can put a rectangular grid right on top of that, and it should end up right there. Okay, so let's see if that works. Right, let's graph the point. 2, negative 200. Okay, so I start out by going 2 units, which way? To the right. And then negative 200 is which way? Clockwise. So if I go all the way around, that's 180. And each one of these lines is 15. So how much more do I have to go?
20.
So I got to go 15 more plus
About a third.
a little bit. Okay. So yeah, each one 15, 30, 45. Yeah, each one's 15. Okay. Any question on that? Now if I put a rectangular grid right on top of it, it should be almost 2 units to the left and a little bit more than halfway up 1 unit. Okay, let's try it. So, let's see, background. And I need the one that's the right scale, so I think it's large. Okay, does that look like it is that coordinate? It's not quite 2 units to the left and a little bit more than halfway up. That's where it should be. Any questions on that? Okay, try that one on your own. See if you can convert that to rectangular. All right, somebody give me my formula for the x coordinate. How about Bill? Did you get the formula for x?
3 cosine 5 pi over 6.
3 cosine 5 pi over 6. And how about the formula for y? Cameron? 3 sine 5 pi over 6. Now, 5 pi over 6 is a multiple of pi over 6. Okay, so we should be able to get a nice answer for that. Maybe it has a square root of 3 in it, square root of 2. The last one, 200 degrees, is not a multiple of 30. It's not a multiple of 45, so you had to round it. Let's find cosine 5 pi over 6 first. Okay, and I'm going to switch back to radians.
Just change it to degrees.
Or I could change the degrees. Yep, either way. Okay. What is that number?
You forgot the 3.
Yeah, I did. I didn't put the 3 in yet. So what's negative 0.866? No, what's equivalent to negative 0.866? It's a square root.
3.
Square root of 3 over 2, but it's negative. Yeah. Okay. So that's square root 3 over 2. And it's negative. And that was times what? Times 3. So our x value is negative 3 root 3 over 2. If your angle is a multiple of 30 or 45, you do need to be able to do that. All right, sine of 5 pi over 6, that's going to come out nice. You won't need a square root to represent. Yeah, it's going to be a half. Change it to sine. Okay, 1/2 and then times 3. We get 1. Okay, so my coordinate would be negative 3 root 3 over 2, comma 1. Okay, so again, if I give you an angle that's not a multiple of 30 or 45, I wouldn't expect a root. Okay, just round it to a decimal. But if it is a multiple of 30 or 45, it could ask you for the exact answer. If it asks you for a decimal, that's even easier. Just round it off. Okay. All right, so that was changing polar into rectangular. Let's take a look at the other way. Okay, so it pretty much looks like the same diagram, except this time you'd be given rectangular. Okay? So that means, what would they give you? They'll give you an x and a y. Okay, and your goal is to find what? Radius. Good. And theta.
I said hypotenuse.
All right, let's start with the radius. Okay, how would you get the radius in this triangle? Yeah, which is what theorem? Someone said. Yeah, we're just going to use the Pythagorean theorem. Okay, and what trig function would you use to find theta? Yep, theta would equal the inverse tangent of y over x. Now, inverse tangent will return an angle to you that's always between what two numbers? Negative this number and positive. It's always between negative 90 and 90. So that means you're always going to get an answer in what two quadrants?
1 and 4.
1 and 4. Which potentially could be a problem because you can have points in other quadrants. Yeah. So I'll show you what you have to do if you're in quadrants 2 or 3 in a second. But the first thing you want to do is graph your point, because the quadrant that it's in is going to change how we determine theta. If you graph it and you're in quadrants 1 or 2, just use the formula we just put up on the board. Theta is inverse tangent of y over x. But if you end up in quadrants 2 or 3, we have to add something in front. Okay, what do you think you'd have to add? 180, yeah. Or pi if you're doing it in radians. Okay, so if you're in quadrants 2 or 3, it's pi plus inverse tangent y over x. Or 180 plus inverse tangent y over x. Where else could my angle be? This still doesn't cover all the possible places it could be. Okay, it could be on an axis, right, in between two quadrants. Well, let's say we had a point right here. Okay, what would be the coordinates of that point?
0.
0, yeah?
0y.
Sure, 0y. We don't know the height, but we know the x value is 0. What would happen if you tried to plug in 0 for x into these formulas? It would be undefined. How come?
You can't have 0 down there.
Right, you can't divide by 0. Right, so the point is, if you're on an axis, okay, you have to just know the angle. Okay? If you're on the positive x-axis, it's 0. Positive y-axis, 90. Negative x-axis is 180. Negative y-axis, 270. So together, now we can figure out the angle for any point, whether it's in a quadrant or on an axis. Okay? There's no other possible cases. Okay, and then the last step, after you get your angle, find your radius. Okay, if you want to do the radius first, that's fine. Finding r and finding theta are separate. Okay, so you're just doing the Pythagorean theorem. All right, so we'll try a couple examples where we convert from rectangular back to polar. Okay. Does everybody have what they need there? All right, so let's try to convert the point 3, -5 to polar. Okay, why don't try that one on your own. Okay. See if you can find the radius. Find the angle. I don't think the angle is going to work out particularly nice, but just round it off. Okay, and then we'll take a look at it together. All right, so what's What's the first thing people tried? Did you find the radius first or the angle? Angle? Okay. So to find the angle, I want to do a quick sketch just to see the quadrant. Okay, which quadrant is this point in? Yeah, right, 3 down 5. Okay, you don't have to sketch it exact. The sketch is just to determine the quadrant. What's the formula to find theta in quadrant 4?
Inverse tangent, y over x.
Okay, inverse tangent, y over x. Okay. And what's y in this case? Yep, and x, 3. And in degrees, did anybody get, just round it to 2 decimal places? Yep, Dominic.
Negative 59.04.
Negative 59.04. Now, remember, once we get this point, there's 4 different ways we can write it. Positive radius, positive angle, negative radius, negative angle, all the different combinations. We'll see what happens. Maybe we'll leave it like that, or I'll show you how to make it positive. And how do I find my radius?
R squared
Mhm.
equals x squared is y
R squared equals x squared
plus
plus y squared.
so it's a square.
So it's the square root of,
34.
yeah, let's just write that. So R is square root 34. Right, so one way you can write your point is R, comma, theta. What if I wanted a positive angle? What could I do to this number?
360.
Yep, that's one way. Just add 360. I could also do it with a negative radius, and then you'd be starting 180 degrees on the other side, so you'd have to figure out your angle. But we don't have to get into that. Okay. Any questions on that? Okay, let's do this one, but we'll do it together. Because it's on an axis, the angle should be something we memorize. So what's the angle for that
It'd
one?
be 90 degrees.
90 degrees.
No, it's the 6 going on the line, so it's colors.
Okay, that's up 6. Okay, so 90 degrees. And you can do r squared equals x squared plus y squared, but what's my radius?
It's
6. It's 6 units from the origin. Okay, so if I was going to write this point, 690. Somebody give me one other way you could write it? 6 negative 270.
Yeah.
Yep, that's another way. Okay, and we went through all 4 ways. So any questions on what we covered with polar, specifically changing between polar and rectangular? Okay, tomorrow we'll go back to the graphing calculator a little bit, and we'll graph things in polar. Okay, so I'll show you how to graph an equation. And then I'll show you how to convert between parametric and polar, polar and parametric, and parametric to function. We already did that yesterday. So you'll be able to convert between all 3, parametric, polar, and functions. We'll look at that tomorrow. Right, so on 492, okay, it's just 1 through 16 all. Okay, 1 through 16 all.